Hello students, in this session we are going to discuss hypothesis testing procedure for the equality of two population means for small sample. When we say small samples, this is strictly the case of both n1 and n2 less than 30, sigma 1 and sigma 2 unknown. So we have two situations regarding the shape of the distributions or the behavior of sample data. If we are given an assumption right there in the question that the data related to two different samples are approximately normally distributed, then we have a choice to go for a parametric test, which is T here, mentioned at the terminal point of this branch. Similarly, if we are given an assumption in the question as either the two data sets are approximately symmetrical or the two data sets have the same or identical shape. So in that case, we have an option to go for a non-parametric test. So continuing with the parametric approach, we have to see if the given samples are independent samples or dependent samples. So we will discuss this difference between independent and dependent samples after completing the applications of pool-T and non-pool-T definitely. Okay. So if the cases are independent samples, that we need to recognize after reading the question and looking at the data carefully. So we have again two options to deal with. First of all, we will perform equality of variance test, that is F test. If the null hypothesis, that is based upon equality of two variances, is not rejected, it will endorse, in other words, the case of equality of variance. So if variances are equal, then we know that we have to go for pool T. If the variances are found unequal, then we have to go for a non-pool T procedure. In case of a dependent samples approach, if we identify after looking at the question that the data structure indicates that this is the case of dependent samples, then we have to go for paired T test. Similarly, going to the other option of approximately symmetrical behavior of the dataset, when the outcome is the application of non-parametric approach. In that case, if we found that the data or sample data are independent samples, then we have to go for M test or Mann-Whitney test, we call it. If data or sample data have the structure of dependent samples, then we have to go for paired W or paired Wilcoxon sign rank test that you have already applied in case of one population non-parametric test approach. So you can notice one thing, that whenever we are dealing with the dependent samples, whether it is approx normal or approximetrical, we have to go for the test in the paired form. So pair T or pair W are the words indicated as an option. Now, moving to the first application of pool T or non-pool T, I've selected this exercise first for the application of pool T. So I would do question number 10.20 here in the lecture recording, that says, in a packing plant, a machine packs cartons with jars. A salesperson claims that the machine she's selling will pack faster. To test that claim, the time it takes each machine to pack 10 cartons are recorded. The results in seconds are shown in the following table. This is the data regarding packing time from the new machines, and this is the data regarding the packing times based upon the present machine. So ignoring the requirement of the question, we first have to look at the assumption. So assumption should be The packing times of the two machines are approximately normally distributed. So only then we can proceed with the pool or non-pool T approach. So in the next step, what we need to do, if this assumption of approx normal behavior of the two data sets is mentioned in the question, in the next step we have to perform a test of equality of variances at the first place, so that we can decide on the basis of test result whether we need to go for the pool T approach or the non-pool T approach when we are going for testing the equality of means. So this is in fact the two-step procedure that we need to follow for pool T and non-pool T. The first thing that equality is that the equality of variance test. So part A, let's suppose it is mentioned that test the hypothesis at 5% significance level that the standard deviations of the packing times of two machines of two machines differs. So test the hypothesis that the standard deviation of packing times of two machines differs. So what we need to do, we need to perform equality of variance test for this purpose, where H naught we state as sigma 1 square equals sigma 2 square. So we are directly going for the variance because F test is based upon the variance structure. So that's two tail test we are going to perform here. Since we are performing a two tail test, given value of significance level needs to be divided by 2 so that it can be equally assigned to two tail and regions. We define test statistic, and test statistic is F that has a formula S1 square is to S2 square, sigma 2 square is to sigma 1 square. Now we go for the critical region. We know that F follows a positively skewed behavior both the data sets have the equal degrees of freedom. F 0.02599, and the lower bound we indicate as F 0.97599. So what we need to do, we need to look at the value 0.02599. So we are now moving to the F table. We need to look for ninth column and ninth row that we can find out in this ninth column on this page. Ninth column, ninth row, 0.025 is giving us the value of 4.03. You can see. So that's 4.03. And what we know is the lower bound of 0.975, we can approximate as 1 upon 0.02599, that's 1 upon 4.03, and that will be equal to 0.248. So this is the working that we need to perform when we are going to determine the lower bound for f test. So that's h naught would be rejected if f calculated is either less than 0.248 or it is greater than 4.03. Now in the next step we go for computation as usual, where we need to take into account the values of the standard deviations given in the question. So let's refer to the question that says standard deviation of 0.685 and 0.750. So 0.685 and 0.750. So better is to take it as whole square, and then this ratio of sigma 1 is to sigma 2 square, whenever the two variances are given equal, then the ratio of sigma 2 square is to sigma 1 square will be equal to 1. So at this place we will substitute 1, and now we are going to determine the answer. So the ratio is no 0.685 divided by no 0.75 and raise it to square. 0.834 is the calculated value of f. Now consider this value, calculated value of f, where it is falling. It is falling between 0.248 and 4.03. In fact, it is falling in the non-rejection region. Therefore, we can write down our decision as, since f calculated does not fall in the rejection region, therefore h naught is not rejected. What does it indicate? That the variances should be treated equal or considered equal, because this is what is stated in h naught. And we write down conclusion, and you know the words for the conclusion. The test results are not statistically significant at the 0.05 significance level, and data do not provide sufficient evidence to conclude that the standard deviations of packing times of two machines differ. Now, moving to the next step of performing the equality of means test, since the null hypothesis of equality of variances is not rejected, we can now consider variances to be equal, and if variances are considered equal, then we go for pool T procedure, we know. So pool T test we are going to perform on this data, and again we will copy the data. The number of observations are equal, and the mean values are 42.13 and 43.23. So x1 bar is given as 42.13 and 43.23. And x2 bar is 43.23. S1 and S2. S1 is given as 0.685 and S2 is given as 0.75. Now, what is the nature of test? For that, we need to read the requirement of the question, that do the data provide sufficient evidence to conclude that on the average, the new machine packs faster. And notice one thing, that new machine is given first in order. And we need to apply the logic before stating H1. Regarding new machine, the claim is it packs faster. Faster means it is taking less time on the average. So this is the new machine. So new machine is the first mu value or mean value is less than the second machine. Faster means taking less time on the average. Alpha equals 0.05. No need to divide alpha by 2. Now here we will apply or use the formula for pool T. T equals x1 bar minus x2 bar minus mu1 minus mu2 divided by SP times the square root of n1 plus square root of n2. Now we define critical region. And for critical region, we need to refer T-table as the case of left tail test and 0.05 significance. Now we refer T-table, and that's 9 degrees of freedom each that belongs to each data set. So T-table what we'll do, we'll refer the T-table, referring the T-table for the degrees of freedom of n1 plus n2 minus 2 that is given as a part of the formula of SP squared. It gives us 18 degrees of freedom. Referring T-table for 18 degrees of freedom with 0.05 significance level would give us the value of 1.734. We will indicate this as minus 1.734 since it is falling or located on the left part under the curve, and we state critical region accordingly as H0 would be rejected if T calculated is less than minus 1.734. Now in computation step, we are first going to compute SP squared value, substituting n1, n2, s1 square, s2 square in its places in this formula, and I have worked out this answer already after substitution. SP squared value is coming up as 0.516. When we take square root of SP squared to make it substitute in the T formula, so SP equals 0.718 we are getting. Now substituting x1 bar, x2 bar, n1, n2 and sp values in the t formula, this is how we get the answer. T value or calculated value of t is coming up minus 3.426, which is clearly falling in the rejection region under the curve, and we can take our decision accordingly. Decision can be written as, since t calculated falls in the rejection region, therefore h naught is rejected, and we can write down the conclusion accordingly as, the test results are statistically significant at the 0.05 significance level, and data provides sufficient evidence to conclude that the new machine packs faster. Why we are saying this? Because if we look at the alternative hypothesis, it is mu1 less than mu2. Mu1 here indicates the mean packing time of the new machine to pack 10 cartons, whereas mu2 refers the mean packing time of existing machine to pack 10 cartons. So it is mu1 less than mu2 in favor of which the rejection goes on. Therefore, it indicates that mean packing time of the new machine is less than that of the existing machine. Therefore, we can conclude that that the packing time of the new machine is less, and consequently new machine packs faster is our conclusion. That's all for now.